Today we're going to solve systems of inequalities, and we've solved inequalities in two variables before by taking and graphing. Let's just do a quick review. So if I want to solve y is greater than x minus 2, I'd simply take and find the y-intercept, which is negative 2, do rise over run of 1, dotted line, because it's strictly less than, or greater than for that matter. Take a sample point of 0, 0. Ask the question, is 0 greater than negative 2? The answer is yes. And then shade the graph. So that's a solution to inequalities in two variables. Now, I'm going to find a solution to a system of inequalities in two variables. So in this case, I have two equations I'm going to have to graph. First one being y is less than or equal to negative 2x plus 4. So I'm going to go up to 4. Slope of negative 2 down to over 1. Since it's equal to, I can solid line. And then I'd have to shade, so I'll pick a sample point of 0, 0. So I ask, is 0 less than or equal to 4? The answer is yes. So I'll shade towards 0, 0. And then I have to graph another equation. So I'm going to go down to negative 4. Do a slope of up 3 over 1. Since this is also equal to solid line, sample my 0, 0 point and ask, is 0 greater than or equal to negative 4? The answer is yes, so I shade towards 0, 0. And you'll notice now that I have green and blue overlapping in some regions, just green in others, and nothing in others. Where the overlap is the solution for my system. And it asks, is negative 1, 1 a solution of the system? Well, where is negative 1, 1? Negative 1 and 1 is right around here, this red dot, and that's in my double shaded region. So negative 1, 1 is a solution. And if you didn't know that otherwise by looking at the graph, you could actually plug that point in and see if it solves both. Let's just do that for the heck of it. I have 1 is less than negative 2 times negative 1 plus 4. So that's 1 is less than 6, which is true. And then 1 is greater than or equal to 3 times negative 1 minus 4. So is 1 greater than or equal to negative 7, and that's true. So it works. Let's go ahead and do another. Now, in this case, neither one of my equations is in slope-intercept form, so I'm going to go ahead and do that. I'll take and subtract x to both sides of the top equation, giving me 2y is less than negative x plus 4. Divide both sides by 2. And get y is less than negative 1/2 x plus 2. Second equation, I'll take and I think it's probably just easier to add y to both sides and subtract 6 to both sides. That gives me 3x minus 6 is greater than y. So in this case, I'll graph 2 up, down 1 over 2. and I'll dot that line. Check to see if 0, 0 works out for me. I've got 0 less than 2. That's true. Then on the next equation, I will go down to negative 6, go up 3 over 1, and I will dot that as well. Check to see if 0, 0 works. Is negative 6 greater than 0? The answer is no, so I shade this side. My double shaded region is here. And is 0, negative 2 a solution? 0, negative 2 puts me right around here. So it's not in the double shaded region. So 0, negative 2, not a solution. Again, we're going to have to put this in slope-intercept form. I'll add 5y to both sides of the first equation, or 5x, I'm sorry. So I have 2y greater than or equal to 5x plus 8, divide by 2 to each term. Y greater than or equal to 5 halves x plus 4. Second equation, subtract 3x to both sides, get 4y less than or equal to negative 3x plus 12. Divide by 4 to both sides, get y less than or equal to negative 3/4 x plus 3. And we'll go ahead and graph those two. Go up to 4, up 5, over 2, 5 over 2. Connect the dots, and I can go solid line here. Use 0, 0. Is 0 greater than or equal to 4? The answer is no. So I'm going to go away from that. And then go up to 3. Go down 3 over 4. Check 0, 0. Is 0 less than or equal to 3? The answer is yes. Double shaded region right here. So now in this case, both are in slope-intercept form. First equation, notice it doesn't seem to have a y-intercept, but there is one of 0. So I start at 0, go down 1 over 3. I can dot the line. But in this case, 0, 0 is not going to help as a sample point because 0, 0 is actually on the line. So I'm going to use another point. I'll go sample. In this case, let's go 1, 1. So that'll be this point right here. I'll use as a sample point. And if I put 1 in, is that greater than negative 1/3? The answer is true. So I'll shade this way for the first equation. Second equation, do green, go down 2, 3. With the negative type, go up 5 over 1. Dotted line again. I can use 0, 0 this time because it's not on the line. 0 less than negative 3. The answer is no. Double shading. is in this region here. So you'll notice we have y is less than 4 and 2x minus 3y is greater than or equal to 9. The second equation needs to be put in slope-intercept form. I'll do that, subtract 2x to both sides, I get negative 3y greater than or equal to negative 2x minus 9. Divide by negative 3 to both sides. Since it's an inequality, I have to take and turn that inequality sign around. So I get 2/3 x plus 3. Now I'm going to graph both. Y is less than 4. Well, here's y is equal to 4. And here's y is equal to 4. And here. It doesn't matter what x is, but y's got to equal 4. And I can solid line that across. So it's a horizontal line. And where the y value is less than that? Well, obviously below. So I would shade below here. If I graph the second equation, go up to 3, go up to over 3, and I go ahead and connect those dots with a solid line. Use my sample of 0, 0, and say is 0 less than or equal to 3? Sure is. Double shading is all this area here. Last example, we'll take and put these in slope-intercept form, so that's y is greater than or equal to negative x plus 5, and y is less than or equal to negative x plus 1. Go ahead and graph that. There's 5, down 1 over 1. Solid line to connect. Pick the sample point of 0, 0. Is 0 greater than or equal to 5? The answer is no. So I shade away from 0, 0. And then we go up to 1, down 1 over 1. Like so. You'll notice these lines are parallel. They'll never intersect. And I use 0, 0 as my sample point, so is 0 less than or equal to 1? Yes, it is. So shade towards 0, 0. And if these lines will never intersect and my shading's going away from each other, there's no solution.